Camilo Fosco. I'm a PhD student with Oda Oliva, and I'm working on computer vision and cognitive science, mostly trying to understand certain processes in the brain and trying to mimic them with machine learning algorithms. So I'll start with one of the projects related to deepfakes. What we're trying to do there is to essentially generate what we call deepfake caricatures, which are a distortion of a fake video that makes its artifacts extremely visible. So what happens right now with deepfakes is that there are fakes that are more and more believable and harder to detect to the human eye. And there are multiple pieces of research that show that misinformation gets transmitted in like a first few seconds of hearing something. And on top of that, once you hear a piece of misinformation, even if you get confronted with other information later on that disproves that misinformation, that already generates some bias in your brain that affects your decision making. So if you can stop it at the source, your measures to counteract misinformation become more effective. And that's what we're trying to do with these techniques. So the idea is we want to build a model that you can pass any video through it, and if the video is real, it doesn't distort it. If the video is fake, it detects what parts are like small artifacts that usually are easily detectable by humans, and it amplifies those artifacts. The way that it works is you essentially receive the video. That video gets sent to multiple kind of separate pathways. One of them is kind of our artifact module, and that module estimates an artifact heat map on the video that would match what humans think that would be fake or that would correspond to an artifact in the input video. So yeah, you take the video, one of them goes to that artifact module. That artifact module is supervised with human heat maps that we collected with human experiments. And that module generates a heat map that tells the network, okay, these parts here are very likely to have artifacts or already have visible artifacts. Then there's another part that essentially corresponds to a detection module that processes that video in a more traditional manner and then receives the information of the heat map to make the final decision. At the same time, that heat map gets fed into our caricature module that essentially utilizes directly the input video with that heat map to generate the distortion. And the output that you receive from our entire pipeline is kind of the deepfake caricature, but at the same time a prediction of whether the element was true or fake. And because the two branches kind of communicate between each other, that's what allows us to tell the caricature module to not do any modifications if the artifact map doesn't have any kind of clearly visible artifacts, or if the detector module is saying this is clearly not a fake. I've learned so much from this place, from everything, from my collaborators, from Aude, my advisor, from the entire community here. This is an amazing place to be, and honestly, it's a constant learning journey.